cotangents in the book are in lesson 4.5 also, as were secant, cosecant. So officially, unofficially, whatever, I call this lesson 4.5.2. Okay? Where secant, cosecant were 4.5 part 1, this is 4.5 part 2. Now, as we start looking at tangent and cotangent, notice you've got to kind of put all of your sine, cosine information on the back burner. Okay? Don't lose it, because we're not done with it. But tangent, cotangent, it does. It works differently. So, as you look at tangent and cotangent, they are these individual curves. Okay? There's not one big, long connected curve. They're the individual curves. I don't know. As I look at them, do they resemble a curve Yeah. To me, it resembles the y equals x cubed. It's not, traditionally, technically it's not that exactly, but it resembles it. It's that shape of y equals x cubed. Now, you'll notice when it talks about tangent, when you go to draw tangent, first of all, notice it is an increasing curve, like y equals x to the third. And notice it says, when you actually draw it, the first thing you'll do is you'll draw the dot on the origin. Okay. Now, if you look, how far apart are those dots? They're 1 pi. Or, as you look, how far apart are the asymptotes? 1 pi, yes? Because like from 1 pi over 2 to 3 pi over 2 is a pi. So here's our first big difference. The period of tangent and cotangent when we get there is not 2 pi by default. It is 1 pi. Okay, so period is pi. It's all about, the period, a traditional period is pi. You place the dots, and then once you place the dots, the asymptotes can go in between them, and it's drawing the increasing curves in between them. That's the short of what tangent is. Now, here's the deal. We've got to somehow also remember the difference between tangent and cotangent. So, a little bit of helpful thoughts or connections. What is tangent's relation to sine and cosine? No? Okay, so a relationship to pull out of your brains is that tangent x is equivalent to sine x divided by cosine x. Remember when we were learning the unit circle, we said that tangent was y over x, and that is sine x over cosine x. Now, what this means, sine x is on top of the fraction, right? So anytime sine x is on top of the fraction, and it equals 0, what's a 0 on top of the fraction going to equal? Make the fraction equal? 0. So notice, every place that sine is 0, well, sine is 0 right here at 0, yes? And then normally it goes up, comes back down. Sine is 0 at pi. Sine is 0 at 2 pi, yes? Well, notice that those zeros, whenever sine has a 0, that is equivalent to when tangent has a 0. So, helpful to know is that sine x, sine zeros create zeros on tangent. So I wrote sine x zeros equals zeros. Because then what that leads me to talk about is what does cosine be in the denominator do? What happens when you have 0 in a denominator? Okay, undefined. And so 0, anytime cosine equals 0, because cosine's in the denominator, there's an asymptote. Well, think about it. Cosine normally starts up high, right? And we draw it down here and we cross through pi over 2. We have a minimum under pi, we cross through 3 pi over 2. So anytime that cosine would normally be 0, those are going to be asymptotes. Now, in all honesty, you don't have to know that information to do your tangent graph. It is just kind of some connecting information to connect this back to sine and cosine. And it's some information if you forget, okay, which one's tangent? Where do I start? What do I do? It's something that can help. Okay? So, tangent, period is pi. Your dots start at 0. Now, look at cotangent. Cotangent, notice it says the first thing you'll draw is the asymptote. So this means instead of having a 0 at the origin, you're going to have an asymptote. Notice how far are my asymptotes spaced? A pi. How far are my zeros spaced? A pi. What's the period again? Pi. The period again is pi. And that's just a huge thing because everything else we've done has been 2 pi. But here, period is pi. So things to notice. Instead of starting with a dot for cotangent, we start with an asymptote. Instead of it being an increasing curve going up to the right, it's a decreasing curve going down to the right. So when you draw a cotangent, it goes down. And then if we want to make the same connection we made previously, okay, if tangent was sine over cosine, what's cotangent? It's reciprocal. It's cosine x over sine x. So now, since cosine is on top, anytime cosine has a 0, cotangent has a 0. Their zeros match. Okay, think about if we were to draw cosine. Those zeros would match. Since sine is in the denominator, anytime sine has a 0, it's an asymptote. So 0, sine crosses through at 0, 1 pi, 2 pi. Those are asymptotes now. So I'm going to write similar to what I did earlier. Cosine x zeros stay as zeros. Sine x zeros become asymptotes. Okay. You will notice we have a new chart. However, A, B, C, D are still in the same spots on this chart. And really the charts are very similar to what we had in the past. One difference. What did A tell us on cosine, sine, secant, cosecant? The amplitude. How far do we count up and down? Well, look at those tangent, cotangent curves. Do we really need to count up or down? No. So now it goes back to our stretch and shrink days, or stretch and compress, which here it officially says stretch vertically or flatten vertically. If the value of A is a number bigger than 1, it's going to stretch. And I will explain when we actually draw these, I'll show you what I'm talking about, some differences of how to stretch versus flatten. But it's going to go up and down quicker, okay? It's going to be more vertical. If the value of A is less than 1, then it's going to be a flatten or a compress, which means it's going to, instead of going up and away or down and away from the x-axis so quickly, it's going to take a little longer. It's going to not be as vertical, more horizontal. And again, the best thing to do there is show you a picture, okay? If A is negative, it's still going to be a what? sorry guys, I'm just looking for your worksheets that I forgot to get out. But if A is negative, it is a reflection. Ah, there we are. And then, what do you notice here about the period? Why is the period pi over b? Yeah. So, with sine and cosine, and secant and cosecant, our basic period was 2 pi. So we had to divide by b to find the period. Here, with tangent and cotangent, our basic period is 1 pi. So notice you do 1 pi divided by b for the period today. Phase shift is still c over b. Center line is still d. Yes? Yeah. And again, I'll show you guys an idea of what I'm looking for stretch versus flat as we do those problems. Okay. I want to try number 1. Let's see what we can do with number 1. Time is never my friend lately. Oh well. Okay, you can at least write down information for number 1, and we will see if we can talk about it. Same old, I'm writing the information down, right? Okay. Start with center line of -1. Now, I don't know if it's good news or bad news, but that's really the only vertical labeling you'll do. Okay, we don't have to label an amplitude here. But, so center line. The next thing we traditionally talked about was amplitude. What am I going to talk about instead? Is this going to be a stretch or a flatten? Because the number out front is 2, which is a number bigger than 1. This is going to be a vertical stretch. And officially it's by a factor of 2. Okay, the key is we're going to stretch it as opposed to flatten it. What's my period? Pi over b, which is pi over 6 in this one. And do we have a phase shift? Opposite the sign, c over b. And so, negative pi over 6. Okay. Now, as we go to label, my period is pi over 6, right? So that means we're going to have to label in sub-sixth. By the way, sine, cosine, my expectation is 1 cycle minimum, right? Well, notice 1 cycle here is 1 curve. With tangent, cotangent, I usually ask for at least 2 cycles. With tangent, cotangent, it's easy to do lots of cycles. It's not, you don't have to think as hard. But, so, if my period is pi over 6, we need to label some pi over 6, right? So, I'm going to say 1 pi over 6. And then I'm going to go ahead and do another one. And I'm going to call it 2 pi over 6. Some of you that's going to bug, though. 2 pi over 6, if you prefer, is pi over 3. And I don't care which way you label it. If 2 pi over 6 works better for your brain, then leave it that way. Now, our shift is also left, isn't it? So I'm going to put an equivalent marking left pi over 6. Okay. Now, with sine, cosine, each period had to be broken into 4 pieces. I just need each period broken into 2 pieces. So if a period is pi over 6, I just need 1 marking. So I'm going to put 1 marking in between each of those. If you want, those would be called what? Half of 6 is 1/2 of a 6, is a 12. So this would be like pi over 12, negative pi over 12. Over here, I'm going to do it, 3 pi over 12, but that's really pi over 4. Okay. Now, which type of graph am I doing here? Tangent. No! That is, I thought I had another minute. Man, oh man. Okay, so that is a horrible spot to end. Definitely we have to talk about that one. If you want a worksheet, you can have it, but I'm not sure you really know enough to do a lot with these worksheets, considering we didn't get to this one. So I guess I'll give you the worksheet tomorrow. Virtual, if you're still there, the worksheet is available online if you want to go ahead and get it printed off or however you're doing it. Thank you, you too.